Do you hear me?
Yes, Doctor. Yes, Doctor. I can hear you.
Okay.
You can start. No problem, Doctor.
All right. Just I want to know the number of students and their background in soil science. As I see, there are just 8 people in the class.
Now enter. All the student now enter.
Okay. Who is Mr. Hossein Isa Dayak Lafte? And another person is Zainab Kazim.
Zainab Kazim. Yes. Zainab سمعين زينب كاظم.
Yes, and the first
زينب
name.
سمعيني.
Yes, Doctor. Yes, I can hear you. Yes, I can hear you.
All right.
Yes, I am Dr. Zainab from Soil Science.
Hello.
أهلا وسهلا بك دكتورة.
Good afternoon.
حياك الله دكتورة. أهلا وسهلا.
Good afternoon, Doctor. Good afternoon.
Are you soil scientist?
Yes, I am from Soil Science.
That's good. Nice to.
And water resource. Yes.
All right. Nice to hear your voice, and I hope you and your colleagues come to Iran to our Department of Soil Science and visit here.
Yes. Inshallah.
Yes,
and I can hear you.
What is your interest? What is your subject?
Yes, I am from biofertility. Yes.
Soil biology. That's good.
Yes, fertility soil.
And I want to know, is there any students in this class?
I think so.
Because I want to know their background, their soil science background.
Just, Doctor, please, just a moment. I will call them. Okay. I will call them.
Okay.
I will return to call them.
Okay,
Doctor. Okay.
Who is Mr. Hossein Isa Dayak Lafte?
Yes, Doctor.
Hello, good morning.
Hello, good morning.
Actually, I don't know what the time is in Iraq, so maybe I have to say good afternoon. I don't know.
حسين يقول لك هسه عندنا صبح لو ظهر ما يعرف. تقدر تجاوبه؟
دكتور عندنا صبح هسه.
ايه قلنا مورنينج
دكتور.
Mr. Anwar.
Yes, Professor.
Okay, are you a soil scientist?
Yes.
Okay, what is your subject? What's your interest?
I am MTech Master in Power System Engineering.
What engineering? Sorry.
Power System Engineering.
And do you have any master or PhD students, or just you have bachelor students?
No.
No PhD students?
No.
Okay. So, Mrs. Razi, Mrs. Zainab Kazim told me that I have to wait.
Doctor, please. The most of the culture have lectures today. Today is a busy. Today are busy. The most of them are busy, Doctor.
Okay.
We're sorry very much. We're sorry. But never mind. We
so can I start now?
We can.
Can I start now?
No. Yes. You can start. Start, Doctor.
Okay. Have you got any PhD students in your department or master students?
Yes, but the most of them have a culture today. Today are the busy. The most of
No,
them
no,
are
no.
busy. Yes, Victor.
My question is your university, your Department of Soil Science. Just you have got bachelor students or postgraduate students as well? I mean the program, postgraduate program, master program, PhD program. Have you got in your department?
Victor, the specific, many of the specific have a cultures today. دكتورة نجلة, دكتورة هيفاء, today is busy يعني.
All right.
Today is
How many?
busy. Your
Okay.
culture شوية. The time of the culture, دكتور.
Okay.
The
How
time of
many?
the day.
How
Anyway,
many academic?
any day. Anyway,
Okay.
we can interact with you.
All
We
right.
can interact.
How many academics you have got in your departments? How many?
The soil science, دكتور. The soil science have, I think, some
All
of يعني, not all يعني.
Okay. So let me start my presentation. Is that all right?
Okay, doctor. Can you
Okay.
start? Can you start?
All right.
Okay.
So I'm going to talk about soil pollution, and my name is Amir Fotovat. I got my PhD in soil science in 1996 from the University of Adelaide in Australia. My interest is environmental soil chemistry. I've got some projects and students working on importance of soil pollution in arid and semi-arid soils, calcareous soils. As you know, there are a lot of calcareous soils in our country, and I think there are many calcareous soils in your country as well. Our faculty has got 10 departments, as one of them is Department of Soil Science. We have got some colleagues working on soil biology, soil physics, soil erosion, soil classification, soil fertility, and also I work on soil pollution. We know that around the world we have got a serious problem which is called overpopulation. Everybody is familiar with overpopulation. And what we estimate or what we predict, the population is increasing seriously. In 2060, our population will reach 10 billions. So all these people need food, all these people need land for agriculture to produce different types of agricultural production: wheat, barley, corn, rice, everything. We need our main sources in the environment. As you know, one of the most important resources is soil. Soil is an unrecoverable thin layer in our planet. You know, it is very thin. Everybody knows that it takes more than 500 years to 1 centimeter of soil is produced. But at the same time, even in couple of minutes, that soil can be destroyed. Unfortunately, soil is not renewable, is not recoverable. We can't create or produce soil by ourselves. We need the nature, all the stones, mountains, weather, and other factors in the environment work together to create soil. I know soil is not the only important resource for us. We need water as well. We need air. We know that we have got a lot of problems in water, clean air, and unfortunately in last centuries, human being has started to dig, to destroy, to vanish the planet. We have got a lot of problem in terms of water shortage. And also we have got a lot of problem in our soils. We know that soil affects our lives. Not only our lives, it affects the food we eat. It impacts the water we drink. It influences the air we breathe. And actually, it can affect all living things, all living organisms, microorganisms, including human beings, mammals, insects, microorganisms, which we know these microorganisms are very important, At the same time, human activities are the main sources of soil pollution. We are facing soil pollution during last decades. This problem is happening not just in my country, around the world, everywhere, in all countries, more or less, in all countries. We know soil has got different components. Let us look at soil forming main components. All soil scientists and even all soil students are familiar with this picture and with these components. If we consider soil as a whole bulk of matter, if it is 100% in terms of volume or weight, we know that half of typically half of that is made of minerals and organics, and rest of them includes air and water. Depends how dry or wet soil is. In a saturated soil, water fills all 50% of this volume, and the dry soil, it goes to 0%. On the other hand, in the mineral and in the solid phase, In solid phase, we have got two very vital and essential compartments: minerals and organics. Typically, it is said that soils have got 5% organic matter, but we know that our soils in Iran and even in your country and in many arid zones, the organic matter is very low. Maybe less than 2%, even less than 1%. Actually, when in Iran we face a soil with more than 2% organic matter, we say this soil is very fertile. This soil contains high organic matter, whereas a typical soil normally is expected to have around 5% organic matter. So there are three important phases: solid phase, solution phase, and gaseous phase. We know there are a number of reactions and equilibrium between these components. In minerals, we are familiar with three important compartment particles: clay, silt, and sand. The most important compartment are clays. Clays, all particles with less than 2 micron or micrometers solids in soil, we call them clay. At the same time, all particles with less than 1 micrometer size are called colloids. Colloids and clays have got unique properties. I can say it is a sort of miracle of God. There is a very strange but interesting structure in clays and clay colloids. Although silt and sand cannot play very important role in chemical properties of the soil, but their physical influence and impacts are very important. Let us focus on clay and colloids. We know colloids and clay colloids have got a lot of charge on their surfaces, mostly negative charge, and also at the same time positive charge. There are three main processes in soil: ion exchange, mineral dissolution precipitation, and organic complexation. These three processes, or these three properties, are most important characteristics of clays and clay colloids. In ion exchange, we see that any particle, any colloid particle, can exchange a lot of ions like cations and anions. They can exchange from the surface to the soil solution. Soil solution is the most important pathway in the soil. all plants absorb or uptake their nutrients such as phosphorus, nitrogen, potassium, and also many micronutrients or trace metals such as iron, manganese, zinc, copper, and these types of elements. Plants absorb these ions from the soil solution. Actually, in terms of soil chemistry, every chemical reaction happens in soil solution. If we want to know soil, we have to know and learn what happens in the soil solution. Soil solution is in equilibrium with colloids, with minerals, and also with organic matter. There is an equilibrium between ions or exchangeable ions. There's an equilibrium, as I said, between clay colloids, clay surfaces, and also soil solution. These relationships, this equilibrium is very important. When an ion, doesn't matter cation or anion, comes to the soil solution and enters the root, the concentration of ions in the soil solution decreases. Upon decrease of ions in the soil solution, there is a disturbance in equilibrium. Actually, equilibrium changes to not equilibrium due to the changes or differences in terms of ions concentrations. A lot of ions detach from the soil colloids and come to the soil solution to reach again the equilibrium. On the other hand, when we give some fertilizer to the soil, suppose we add some potassium fertilizers into the soil, these potassium ions are solubilized, go to the soil solution as soluble ions, and when again the concentration in these two systems changes, again a lot of potassium ions go to the exchange phase and sit on the exchange sites. And in this way, actually, soil is a sort of pool to save and to keep these elements for future application and future use of plants. At the same time, mineral dissolution and precipitation is very important. There are a lot of different minerals in the soil in solid phase. Many of them are insoluble or quasi-soluble. When we say quasi-soluble, it means that its solubility is very low, but never its solubility is zero. Actually, nothing is not in soil insoluble. Everything in soil is soluble, but the solubility is different. I know that, but nothing is insoluble in the soil. even rocks, even stones, even calcium carbonate, or even gypsum and other minerals. Minerals are dissolved even in very low concentrations. They release a lot of ions to the soil solution. Suppose we look at the rock. If we put a piece of rock in beaker, in chemical beaker, in a glass of water, I mean, in a glass of distilled water. Everybody knows that distilled water has got no ions. It is not electrolyte. It is pure water. But when we add a piece of rock and we shake it for just 2 minutes and leave that rock to stay in the water. After that, if we go and analyze the water with chemical processes, we will find some ions in the distilled water. It means even during that 2 minutes, some ions, cations or anions, come to the solution, enter the solution. I know this amount of ions are very low, but if we consider this reaction during rather than 2 minutes, we consider it during 1 month, 1 year, 10 years, 1 century, and millions of years. In that case, we will find a lot of ions in the soil solution. And we know that all plants and living organisms are uptaking these ions from the soil solution. Let us move to organic complexation. Organic matter is another compartment or component that present in solid phase. What is organic matter? Where it comes from? What is its behavior? There are a lot of living organisms growing in the soil, such as plants, animals, microorganisms, insects, larvae, a lot of worms. They are living in the soil. When they die, their body, which is full of carbon, hydrogen, and oxygen, which we call them organic matter, is left in the soil. What will happen? A lot of microorganisms will start decomposing these organic matter, these fresh organic matter. This fresh organic matter is an excellent source of food for these microorganisms. Bacteria, fungi, actinomycete, viruses, all of them. This very complex decomposition process is ongoing. It is happening all the time, non-stop. many factors such as humidity, such as temperature, such as water content, such as light. All of them can affect the speed of decomposition. At the first and early stages, decomposition is quite fast and quick. But at the same time, the speed of decomposition decreases, and maybe when we consider a leaf, a part of roots, a part of plant stem, if we leave it in the soil, we will see after a while, maybe 1 week, 1 month, couple of months, that piece of plant has been decomposed entirely. And we know that the product of organic matter decomposition is a very famous and valuable material. We call that humus. Humus is a source of a lot of nutrients, plant nutrients, and also a source of a lot of chemicals like organic acids, which are very important in the soil. They play an essential role in the chemical properties of the soil. At the same time, influence of organic matter on biological system of the soil is very important. Soils without organic matter will have a big problem in terms of soil biological behavior. All microorganisms, all living organisms in the soil, their life depends on the presence of organic matter in the soil. But these two properties, or these two effects, I mean chemical effects and biological effect of organic matter, these two impacts are not the aim and the task of organic matter. One of the most important influence or effects of organic matter is their effect on physical properties of the soil. Physical properties such as aeration, permeability, soil structure, aeration, and these sort of physical properties. So we have to know the soil very well in terms of physical, biological, and chemical aspects. Soils are subject to direct use of pesticides application, a lot of pesticide or chemicals, fungicides, herbicides, bactericides are applied in soil by human beings, by farmers, to produce higher amounts of yield. At the same time, we improperly treat the soil. Improperly treated organic fertilizers and overuse of mineral fertilizers. I'm sure everybody knows that how much farmers add chemicals and mineral fertilizers to the soil. I don't know in your country how much fertilizers is added to the soil. but I've seen a lot of farmers around the country are adding huge amounts of chemical fertilizers. Fertilizers such as urea, such as superphosphate, such as potassium sulfate or potash, ammonium phosphate, zinc sulfate, copper sulfate, and a list of very different fertilizers. One of the very serious problem in our soils is overuse of mineral fertilizers. Suppose in a farm, the plant needs 200 kilograms of superphosphate or nitrogen fertilizer, but you see farmers are using maybe 2 times, even 3 times, sometimes more than 1 ton of fertilizer is added into the soil. We know that much of these fertilizer is not uptakeable, or is not absorbed, or is not useful for plants. What will happen? Most of these fertilizer will be left in the soil. At the same time, polluted water, urban waste, which they release from industrial production, waste disposal, and landfill, and etc. These, which each of them has got their own chemical properties, are added to the soil. These chemicals, with their own chemical properties, will affect the soil, will affect chemical composition of the soil solution. And that the chemical composition of the soil solution changes, we know a lot of essential phenomena and processes are happening in the soil, which affect microorganisms, plants, and eventually will affect human beings. There are also some other indirect impacts. Not just direct impacts. Indirect or indirect impacts of the soil. Soils are subjected to indirect impacts of atmospheric deposition from mining. A lot of mining activities are ongoing in several countries around the world. And then when we dig, we go to use the mine, we have to break that rock from its native site, and when we go and we dig mines, actually we are disturbing the natural equilibrium. A lot of mineral materials will come out and enter the atmosphere. They go everywhere, and eventually in downstream they will deposit. So atmospheric deposition from mining is a serious source of soil pollution. There are a lot of smelters. Actually, most of the factories has got big smelters. They are melting rocks, they are melting metals, and for melting those rocks and metals, there is a huge amount of fuel which is used. From these smelters, there are a lot of smoke, a lot of nitrous oxides, sulfur oxides, and other forms of elemental oxides coming out of the smelters. They enter the atmosphere again. They move far away from that smelter, and eventually they reach soil, and it ends up with soil pollution. Waste incineration. It is quite common to fire the waste, to get rid of them. Although in terms of health, it is a good practice. It looks very good practice to get rid of pathogens, to get rid of microbes. But at the same time, there are a lot of nitrogen oxide or NOx, sulfur dioxide, and other forms of elemental oxides is producing and entering the atmosphere. Surface runoff. When there is a heavy rainfall, we end up with runoff, surface runoff. Runoff washes everything and takes many parts of the valuable part of the soil, clays, important particles, and colloids are washed away with runoff. So in this way, the soil is getting poor and poor. Everybody is familiar with wind and water erosion. I think all countries located in arid and semi-arid areas are suffering from water and wind erosion. A serious problem. Wind and water erosion is degrading soils. Soil degradation is a serious problem in our soils. Excuse me, just I want to check. Are you hearing me? Is anybody hearing me? Mrs. Hussein, Mr. Hussein, Mrs. Zainab Kazim, Mr. Dakhil Razi, Mr. Ambar. I hope everything is clear for you. Okay. Let us move on and let us move into the next slide. If you want to look at the soil pollutants, and if we want to classify them, there are many various classification of soil pollutants. At the first stage, usually soil pollutants are divided into two main groups: inorganic and organic pollutants. A lot of inorganic pollutants, including metal and metalloids, and also non-metals. If you want to give some examples, the most important metals as soil pollutants are heavy metals. Heavy metals such as cadmium, lead, copper, zinc, arsenic, chromium, mercury, silver, and so on. I will talk about these heavy metals in next slides, and will go and explain in more details their chemistry, their behavior in soil, and also their importance and their toxicity as well. For non-metals, we can name and we can list nitrate as an anion. Nitrate is made of nitrogen and 3 oxygen with a minus charge. Nitrate, it is an anion. It can enter the water table, and its high concentration is not good for drinking water and for mammals and for human beings as well. Normally, a water with more than 45 milligrams per liter or ppm is considered a not suitable water for drinking. along with nitrate anions, ammonium cations, different composition of sulfur, such as sulfur dioxide or sulfur oxide. Many of these materials as non-metals can pollute and can contaminate soil environments. But the inorganic pollutants are not limited to these materials which I talked about. A lot of materials such as radionuclides, uranium, zirconium, cesium, radium, many of them can be found in several parts of the world in soils, and they can pollute the soils. Unfortunately, all of these pollutants can be absorbed by plants' roots. The important properties of inorganic materials is that when they enter into the plant, it is not possible for plant to decompose them. I mean, suppose cadmium enters the plant roots and goes everywhere, in stem, leaves, fruits. Cadmium in the plant is not decomposable. Cadmium always is a cation presenting in the plant, and wherever it goes, it can be toxic for those tissues, for cell, for cytoplasm, for cell walls. It can change the chemical composition of a lot of enzymes, and this can be toxic for that plant. Okay, the next group is organic pollutants. Organic pollutants have got several subdivisions: halogenated, non-halogenated, aromatic, aliphatic, with several chemicals: DDT, PCBs, polycyclic biphenyls, chloroform, benzene, toluene. These are some of examples of organic pollutants. The main difference between organic and inorganic pollutants is their potential to be decomposed. Fortunately, organic pollutants can be decomposed by many microorganisms. But again, these organic pollutants can be harmful for many living organisms in the soil. for plants and even for animals and human beings. If we want to briefly look at some of important sources of soil pollutants, mining activities, agricultural practices, petroleum-related compounds, waste disposal, wastewater and sewage sludge. These are some of important sources of soil pollutants. Nowadays, these activities is widespread around the lands of many countries. We have got a number of mines in our country, and I'm sure a lot of mines are in your country, and most of them are working seriously, heavily, and polluting the environment seriously. These pictures are just examples, very small examples of mining activities. Look at this mountain, this part of earth, how far and how deep human being is going down and digging rocks and transporting them to the mining factories to produce several elements and metals, and see what is left. What is left? A very polluted water, a very polluted drained water. A lot of dust from these mines spreading, diffusing, and going around the mines. At the same time, a lot of drainage. With very dangerous chemicals going downstream, going everywhere, and polluting many unpolluted lands and soils. We haven't got enough time to go in more details to influence of mining activities on soil pollution. And just briefly, I wanted to show this slide. Agricultural practices. There are several agriculture activities. Application of pesticides in very vast areas. In more than 100, even 1,000 hectares of agriculture lands, we use pesticides. Consider to this point that when we say pesticide, it includes a list of various toxic materials. Materials such as insecticides, fungicides, nematicides, herbicides, bactericides, with several ingredients and different chemical compositions. Just let us look at this information reported from FAO. In different regions, Africa, Asia, everywhere around the world. This is the application of pesticides in year 2000 compared to year 2017. During these 17 years, we can see how they are increasing. In Africa, from 61,000 tons to around 79,000 tons during 17 years. Look at here, 29, roughly 30, around 30% increase. Asia, 33%. Caribbean, 69%. And South America, more than two times, 104.9% increase. And this value is an average for whole world. And we know that this increasing trend is going on and will continue in next decades if we don't take an action. These pesticides have got different ingredients. Chemicals, toxic chemicals, and at the same time they have got some toxic heavy metals. So along with active ingredients, which we can, as an example, we can name atrazine, 2,4-D, or these sorts of chemicals. They have got toxic heavy metals as well. Look at here. This picture clearly shows improperly discarded empty pesticides containers. They are very important as soil pollutants source. Along with pesticides, we have got another problem in agricultural lands. Recent studies show that there are a lot of antibiotics in soil. Look at this slide. As you see, this slide is showing half-life values for some of antibiotics. For example, amoxicillin, azithromycin, and sulfadoxine, and a list of antibiotics. In terms of days, their half-life changes from a couple of days to even 10 years. Look at this value, 10 years. An antibiotic lives in the soil for about more than 10 years. everybody knows that how these antibiotics can affect microorganisms in the soil, beneficial microorganisms. Many of these antibiotics are absorbed by plants, by root plants, and they enter the tissue, plant tissue, and can be transferred to food chain from leaves, fruits, and reach human being. Fortunately, there are a lot of research studies working on behavior of antibiotics in the soil. I've got some projects, and some of my graduate students are working on the behavior of antibiotics in the soil, in calcareous and in arid soils. Agricultural practices is not limited to fertilizers. Different fertilizers, nitrogen, phosphate, potassium fertilizers, and even trace elements fertilizers are used in different areas in different countries. This is just an example of global use of inorganic fertilizers in agriculture. Million tons, look at the value, look at the unit, million tons from 2010 to 2018. Another important fertilizer is organic manure. I mean, animal wastes. Cow manure, sheep manure. These are some of sources of organic manures. Another source of agricultural activities which can pollute the soil. Agricultural plastic wastes. We can see these farms everywhere. During last 2 decades, using plastics in agriculture are increasingly common. And after the harvesting, all these plastics are left in the soil. But the effect of plastic in the soil is not limited to its effect in terms of physical property. There are a lot of studies during last 10 years showing that all plastics which are left in the soil, their physical and chemical behavior are changing. We know they are actually undecomposable. They stay in the soil for more than 1 to 5 centuries, sorry. One of the very important reaction is changing the plastics to macro and micro and even nanoplastics. PhD students of mine are working on micro and nanoplastic in the soil, in calcareous soils. There are huge number of publications from 2010 onwards working on micro and nanoplastics. Interestingly, Interesting. Listen, I'm not sure you believe or not. Studies show that nanoplastic enter root cells, enter the plant, and goes everywhere. So what will happen? What will happen when we use a lot of plastics and we leave them into the soil? It is very serious concern for all societies. Petroleum-related organic compounds. Okay, I think I'm in short of time. I have to finish, so I will move more quickly, and I will do my best to finish my presentation on time. Petroleum-related organic compounds. Just I want to show a couple of examples. Monocyclic aromatic hydrocarbons which contain benzene ring. We call them as abbreviation BTXs. Benzene in pesticides, toluene in solvents, ethylene benzene in plastics, paints, xylene, detergents, tires. BTXs are very toxic to human and living organisms. And unfortunately, their half-life is very long. Some of them stay and live in the soil for more than a couple of years. Waste disposal. Let us look at the composition of global waste composition. There are different composition, different materials which are present in waste. Rubber, leather, 2%, plastic, 12%, paper and cardboard, 70%, metals, 4%, glass, 5%, wood, 2%, and about half of that is food and green materials. Okay, let us look at the difference of waste disposal. Let us look at this point, that how different countries dispose of wastes. Are we doing any treatment for them? This report is from FAO 2021. This is global treatment and disposal of waste. Actually, average of all countries, developed countries and developing countries. Actually, just 3.7% are uncontrolled. 13% recycled. Some of that is used for composting. Sanitary landfill. 11% for insulation. About 1/3 of that, 33%, are left in open dump. Let us compare into South Asian treatment and disposal of waste. about 75% of that is left in open duct, quite uncontrolled. So it needs to change our attitude. It needs we improve our knowledge. We improve our techniques. It needs to aware our societies and our people to know that this action is very dangerous. Another source of soil pollutants, municipal and domestic wastewater. You know that wastewater and sewage sludge is applied extensively into the land as irrigation water. Wastewater is very beneficial. It is recommended that we do treatment processes for wastewater to recycle that, to use it again in different forms. Wastewater is very important. We know that it provides water, organic matter, and plant nutrients. Normally, wastewater contains nitrogen, phosphorus, potassium, and different types of nutrients, and also a good source of water. And at the same time, it has got a lot of organic matter. Sewage sludge has got a lot of organic matter. But at the same time, unfortunately, there are some toxic materials in wastewater and sewage sludge. If we do not any treatment of wastewater is a sort of must. It is compulsory. The quality of wastewater, for example, municipal or domestic wastewater, we can see how the water is used and it drains from clothes washers, dishwashers, kitchen sink, toilets, bath shower, and different types of water consumption. Produces black water and gray water, which there is no enough time to go in more details. This table is very interesting for me. This table shows household product contribution of heavy metals. Cadmium, chromium, copper, lead, mercury, nickel, zinc, microgram per capita per day. In microgram per capita per day, per person per day. Look at these products. Mouthwash. Open 3 microgram per capita per day cadmium. It contains chromium, copper, lead, mercury, nickel, zinc. Look at this one. Look at this one. Toothpaste. Toothpaste contains zinc, nickel, mercury, lead, copper, chromium, cadmium. Toilet paper, bath soap, shampoo. Shampoos contains these values of heavy metals. Liquid dish detergent, toilet cleaner, liquid bleach. All of these materials are used everywhere, and we need them. as you see, there are a lot of heavy metals coming into the wastewater, municipal wastewater. And all of them are entering water table or wherever the drainage water goes. There is not enough time to talk about soil decontamination techniques. We know there are in situ and non-in situ methods, volatilization, bleaching, chemical extraction, vitrification, isolation or passive method, biodegradation, excavation, thermal treatment. But we know that most of these decontamination techniques are very expensive, and we cannot do in very vast areas, and they are applicable just in small areas, in limited lands. Fortunately, there are some hyperaccumulator plants. We call hyperaccumulator to a plant when it can absorb high concentration of metals. For example, this plant is able to grow well in metals contaminated soils and has a high uptake of zinc and cadmium without any problem. It's growing very well with high concentration of zinc and cadmium. These plants are called hyperaccumulators. This is another hyperaccumulated plant. Nickel-rich sap being taken from a tree in Malaysia. See, this contains high concentration of nickel. As you see, the color is quite green. There are hundreds of milligrams per liter of nickel in this sap, in this plant. We know heavy metals can be absorbed by plants. If we want to compare different parts of the plants, we see roots actually is the first step that heavy metals are absorbed by plants. The concentration of heavy metals in roots are quite higher than shoots and stems, and fortunately, the least concentration, the lowest concentration of metals enters seed and fruits. This is a good news for us. So if there are these sort of plants, or like this, we can use them as extractor, metals extractor from soils. Phytoremediation. There are several planned mechanisms for the uptake and stabilization of organic and inorganic contaminants in the soil. We call this process phytoremediation. Phytodegradation, phytoextraction, phytostabilization, rhizodegradation, phytovolatilization. These are different mechanisms or phenomena which can be used, and actually plant can use these mechanisms to extract metals from the soil, and this way we can decontaminate soil. This is quite environmentally friendly technique. but it has got its own limitations. If we want to list, I've got in short of time, actually I'm in short of time, so let me move. These are some examples of heavy metals, toxic metals, which are found in soils: cadmium, copper, zinc, lead, mercury, cobalt, nickel. As you see, most of them are in cation form with 2 positive charge. Chromium and also arsenic, which mostly are in anion form. Chromate, dichromate, and also arsenite and arsenite. These are in anion forms. Selenite and selenate and other toxic elements in anion form. I think my time is over, so I wanted to talk about the toxicity of cadmium. Let me move to my last slide, and I move to conclusions. Soil is one of the most vital assets. It is very important for us, for human being, for our life. It is the vital assets of human life, and we have to protect that. We have to keep that safe for future generation, for next generations. This is our main task. Also, we as soil scientists or soil science students or soil scientists or in any field of soil science, our task is to get people be aware of the importance of soil and the harms of soil pollution. We have to get the people familiar with soil pollution and its dangers. Actually, I think in general, our role is not to cause unnecessary concern in the society for soil pollution problem. It doesn't need to be exaggerate. We shouldn't create an unrealistic picture. We have to convey a real picture of the problem. So we have to inform the community, and also we have to study and do research to find how soils are polluted and what are the source of pollutants and how we can sort the problem out. And as a final conclusion, soil monitoring should be considered as one of the necessary steps by all countries and governments. All countries, all governments must create good situation, enough money and budget and grants for soil monitoring. Soil monitoring means to check the situation and the quality of soil in terms of pollution. We have to keep eye on soil pollution. Thank you very much for your attention. I'm sorry if my presentation actually was more than, I think, 10 minutes. Okay, thank you very much. If anybody wants to have some references, I can introduce some references at the end of my presentations. This is an excellent book of heavy metals in soils by Professor Alloway, and other references. Thus, I move quickly and show just titles, just a couple of them. There are plenty of papers, manuscripts are presenting in the literature. Okay. Thank you very much. And I'm ready to give my answers to any question if there is.
Yeah. Thank you, my dear. Excuse me, please. Excuse me, doctor. Thank you for this fruitful information. My question, you mentioned the benefit of the water, of the wastewater.
Yes.
But as we know that some of this water contain elements harmful to the plant growth.
Yes, exactly.
How can the issue be treated?
You are asking a very difficult question. That is actually a demanding question.
Yeah.
We have got the same problem. We live in arid country, and we are in short of water. Water shortage is a very serious problem. So, on the other hand, we are using a lot of water and consuming a lot of clean and fresh water and producing a lot of wastewater. I think we have to have got some regulations in terms of governmental regulations. We shouldn't allow to use untreated wastewater to agricultural lands. At the same time, we have to measure the capacity of our soils.
Yeah.
In terms of loading wastewater. I know wastewater contains a lot of toxics, heavy metals. But fortunately, our calcareous soils with high pH can absorb and can precipitate a lot of these heavy metals.
Yeah.
If we measure the concentration of heavy metals, when I talk about wastewater, always I talk about treated wastewater, not untreated.
Yeah.
Not untreated or not treated or untreated wastewater application must be prohibited.
Yeah.
But when we want to use the treated wastewater, we have to measure its concentration, heavy metals concentration, and at the same time we have to analyze our soils. How much calcium carbonate we have got in the soil? What is the pH? And we can calculate what is the capacity of water or wastewater to be added to the soil. And we have to keep that criteria.
Yeah.
Is my answer clear?
Yeah, thank you very much. Thank you very much, my
That's
dear.
all right.
Thank you, my dear. Yeah.
Okay.
Yes.
Yeah. Started, Dr. Dakhil. Started, please.
Thank you, Professor Dr. Amir. thank you about this important subject of soil pollution. My question, I ask you about relationship between water and soil pollution when we using this water for irrigation. And second question, are there the important soil treatment to control of the soil pollution? Ask you you talking the methods you talk in the conclusion. The methods should be considered by all countries. What you mean this step of methods to treatment to control of the pollution or the steps of control this pollution of the soil. Thank you.
Okay, thank you very much for your good question. Treatment of water by soil, actually any heavy metals treatment is very expensive. I mean, when we look at the literature, I think the best way for control of soil pollution is we do some activities and we do our best to not allow the soil to be polluted. I mean, when a soil is polluted, actually we have to we have to raise our hands.
Yes.
Because the treatment is very expensive. Actually, just we can do that in small areas, small lands. But fortunately, I think remediation actually is opening a new area. I know remediation has got its own limitations, but we can. I think I'm quite optimistic. I think we will be able to find some good techniques in near future for remediation. But again, heavy metals actually are those or that part of soil pollution which we cannot solve their problem easily. So the best way to prohibit or not to allow a water is polluted. However, I have seen some projects in some countries and even in Iran. They are actually adding water to the soil with high calcium carbonate, and the water which is coming out of that soil as a leachate, its heavy metals concentration actually is lower than the input water. I know it is very difficult. So the best, I think the best way is not to allow the soil is polluted. Okay.
Thanks.
And I will be very happy to use your experience and to get familiar with your knowledge, and we learn a lot of new things. Recently, there are some studies in nanomaterials, but at the same time, nanomaterials, they have got their own problem. There are some records and reports showing that nanomaterials is entering the plant tissue. So that could be another new problem. Okay. Was my answer quiet and clear? I hope so. Is any other question?
Yes, please. Yes, please. Salam alaikum, Dr. Hassan. Salam alaikum, Dr. Amir. Salam
Dr.
alaikum,
Kazim.
Dr.
Salam alaikum, Dr. Kazim.
Doctor, I would thank you about this useful lecture about soil pollution. So we have many problems in the soil pollution, practically in the Basrah city. Basrah city, yes, many problems and a huge problem. Some trials, research we have done about the to remove or decline the pollutants of the soil But one of them research bioremediation or phytoremediation. This research, yes, Victor, this research was successful, بس intermediate يعني that about this phytoremediation or bioremediation, the heavy metals, to remove the heavy metals, it is still in the soil. It's intermediate, يعني not fully, يعني not fully to remove this heavy metal, not fully. So I would like to ask you about the best ways or the best experiment to remove or decline these heavy metals or pollutants, industrial pollutants or petrol or anything.
Okay.
The best way, because the fate of this heavy metal is still in the soil after bioremediation or after phytoremediation. This is practically of my research. Of my research, yes, Doctor. I thank you very much, and we need more lecture about this subject, for it's useful our lands, Doctor. Thank you very much, Doctor. Thank you.
That's okay. That's all right. Thank you very much for your good question. Actually, everybody knows that just with 1 year planting, we can't take all the heavy metals from the soil. We can't extract all the metals from the soil just in one season. No, it is impossible. Student of mine, actually one of my master students, we study the extraction of lead, cadmium, zinc from a calcareous soil, and we use the cotton, alfalfa, and also helianthus. We calculated if we want to extract all the soil, all the heavy metals from the soil, it takes 180 years. Can you believe that?
Yes.
So it is too long. 180 years.
Yes.
Too long. But at the same time, when we look at the literature, there are some accelerators. I mean, we did another experiment and we add some chelates, like EDTA.
Yes.
And when we added chelates into the soil, actually the speed of plant to uptake heavy metals actually doubled, and we decreased that 180 years to about 90 years.
Yes, Doctor.
About half, but still it is not enough. I know it is not enough.
Yes.
I think we can't extract all the metals from the soil. Actually, it is impossible. At the same time, maybe in future we can find some techniques and some methods.
Yes.
But
Yes.
adding some maybe we find some chelates, and also I think another way which is out of the soil science area is using molecular biology. I mean finding some genes which present in hyperaccumulators, and if
Yes.
we are able to transfer those genes to other plants which produce high biomasses.
Yes. Yes.
In that case, maybe we are able to increase the speed of heavy metals extraction from soil. But I know in phytoremediation, actually, we are in early stages. I think you should know Professor Chani. Professor Chani has worked many projects in the field of phytoremediation. And in one of the conferences, when I visited him, when I talked to him, it was about a couple of years ago.
Yes, Doctor. Yeah.
He believed that in phytoremediation we are in early stages. But at the same time, I took part in a conference in Italy, in Florence, in a biogeochemistry of trace elements conference. In that conference, there was a very interesting paper. They have planted some plants in a nickel-rich or nickel-polluted soil, and they extracted a lot of nickel by plant. And then after harvesting, they had extracted those nickel from their plants.
Yes. Yes, Doctor. Yes.
And actually,
I noticed that.
yeah,
Yes.
it is
Yes.
very interesting. But as I said, we are in early stages, and we need a lot of research and a lot of
Yes.
work we have to do.
Yes, Doctor. Yes.
I hope our research goes with good results, and we have got enough grant for that. And I hope Allah help us to find new findings.
Yes. Thank you very much. Thanks.
I'm quite happy, and it is my pleasure to get familiar with your department, with your facilities, and with your projects. Have you had any studies on heavy metals in soils?
Yes. Yes, Doctor. I
And
have
how you measure
Yes.
how you measure heavy metals in soils? Have you got any atomic absorption spectrometry or ICP or these sorts of equipment?
Sorry, the sound not clear, please. The sound not clear. Can you return answer? Can you?
Okay, I'll repeat that. How you measure concentration of heavy metals in soils? How you analyze?
By spectrophotometer, Doctor. By spectrophotometer.
Okay, you have got atomic absorption.
Absorption, yes.
Okay, and how about ICP?
I don't know.
All
Sorry,
right.
I don't know. Sorry, Victor.
Okay.
Fertility. Sorry, fertility. But I have many, some of the research, some of this about this soil pollution, about it.
Okay.
Yes. Thank you very much, Victor. Thank you.
That's all right. Thank you very much.
Thank you.
Okay, I think we are running out of time.
Thank you, Dr. Amir. Thank you so much.
Thank you very much. I'm quite happy, and it's my pleasure to get familiar with you. And thanks a lot, which you let me to give this presentation. And I hope we see each other. Maybe I come to your university, and inshallah you come to our university, and we have very close relationship. I mean, scientific relationships, and we have got some students coming from your country, and they are very nice students, and I'm quite happy which I'm finding new students. Okay.
Inshallah.
Thank you very much.
Thank you.
Inshallah ta'ala helps everybody. Can I finish my presentation? Can I?
Yes, yes.
Can I?
Yes, yes, Doctor.
Okay, thank you very much. مع
Thank you.
السلامة.
Thank you.
مع السلامة.
مع السلامة. في أمان الله.
في أمان الله. في أمان الله. See you.
مع
Goodbye.
السلامة. مع السلامة. شكرا أساتذتنا الكرام على حضورهم واستماعهم. إن شاء الله استفاديتوا من المحاضرة. أساتذة يقدرون تغادرون حتى نقدر نفتح بعد عندنا سيمينار جديد هسه نريد نفتحه جديد. فتحبون إذا اللي يحب يغادر خلي يغادر على ما نسوي اتصال ويا الأستاذ المحاضرة الجديدة. شكرا استماعكم وحضوركم. مع السلامة. السلام عليكم دكتور. How are you?
Salam alaikum.
How are you?
Dr. Maravish. I'm Dr. Maravish from Currency University of Mashhad.
Yes, yes. I am Anwar from IT Technology Center. Can you share your presentation?
Yeah, okay. I'm ready now.